Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be on Lab 8-2, where we're going to take a look at securing the control plane for both EIGRP and OSPF. And in fact, we're going to be using the HMAC-SHA-256 hashing algorithm with EIGRP, and we're going to be taking a look at some advanced work with OSPF. Specifically, I believe we're going to be creating some keychains that we're going to end up using in order to set up the authentication. And again, the keychain feature, it's interesting. The lab calls for version 15.2 or later, and I've got version 15.3, and that option is not available to me, and we'll actually take a look at it again. And you'll see what I'm talking about. So, as always, I've already configured all of the basic IP addressing information. As you can see, I've got my drawing here. So this is the topology we're dealing with. Again, exactly the same topology that we saw in Lab 8-1. So let's go ahead and dive in. I'll be on step 2. So configure named EIGRP routing, or in other words, 64-bit mode EIGRP. So let's go ahead and say router EIGRP route is the name that we're going to use. Address family IPv4 unicast, and we'll use autonomous system 1. And I'm going to go ahead and set up a network statement for 10.1.1.0, and we'll put a wildcard mask of 0.0.0.3, and we'll use 192.168.1.0.0.0.255. So again, we have a slash 30 that we're using, which is right here. We're using a slash 30 for the subnet mask, and then here we're using a slash 24. Keeping in mind that this is the inverse of the subnet mask. So the subnet mask for 24 is going to be 255.255.255.0, and the subnet mask for a slash 30 is going to be 255.255.255.252. All right, so these are the two networks that we're going to be working with right here. Okay, so we've got that set up on router 1. Let's transition over to router 2, where we're going to do much the same thing. So we'll go from user exec to privilege exec into global config, router EIGRP route, address family IPv4 unicast, autonomous system 1, and we're going to add our network statements in. So 10.1.1.0, and again, it's a slash 30. And then we've got the 10.2.2.0. Now, the lab has this set up, and you can see our adjacency has come up there. The lab has this set up to be a slash 30. However, I wanted to keep the IP address as the last octet the same as the router number. So we went ahead and made this a slash 29. So for a slash 29, right, for a slash 29, the subnet mask is 255.255.255.248. Right? So if we were to subtract this from the all 255s, we would get 0.0.0.7. So the wildcard mask for a slash 29 is 0.0.0.7. So let's go ahead and clear the screen here. And we'll add that wildcard mask in, 0.0.0.7. And we've already got the adjacency up between router 1 and router 2. Now let's transition over to router 3, and let's say show IP let me check something really quick here. Show IP interface brief, and yes, that should be good. I can actually get rid of, and let's go into global config here, and we're going to say default interface serial 010. So we're not using that interface, so we're going to wipe that out. All right. So we're in global config, where we're going to say router EIGRP route, address family IPv4 unicast AS1, and then we're going to say network 10.2.2.0. Now remember, this is a slash 29, so it's 0.0.0.7. We should see an adjacency come up here, and there it is. And now let's go ahead and advertise out the loopback address of 192.168.3.0. And that is a slash 24. So if I wanted to check to see the interfaces, I could say do show IP EIGRP interfaces. And this is going to show me the interfaces on which I'm running EIGRP. So we're running on the serial 000 as well as the loopback 00. If I said do show IP EIGRP neighbors, you can see that I have a single neighbor here on router 3, and that neighbor is router 2. So if we come up to router 2, we'll get a little richer output here. If I say do show IP EIGRP neighbors, and you can see router 2 has two neighbor relationships right now, or two adjacencies, one with router 3 and one with router 1. All right, so now that we've got our basic EIGRP information set up, if I say do show IP route, and actually let's trim this down to just the two EIGRP routes, you can see that here are the two EIGRP routes that we know about, and on router 2 we see both of the loopback addresses, the one from router 1, which would be this one here, again via the successor. Here's our administrative distance, here is our computed distance, right? And that's our composite metric there. Okay, so it's asking us to check to see if we have connectivity here from router 1, so let's go ahead and say do ping 192.168.3.1, and we do. So we can get from router 1 all the way over to router 3. So now we're to the meat of the exercise here. Step 3 is going to be secure the named EIGRP routing process. Now, not only are we going to use HMAC-SHA-256, we're going to use keychains to make this happen. So I'm going to type end and get back into global config here. And the first thing we're going to do is create a keychain. So I'm going to say keychain. Now remember, the name of the keychain is locally significant. So I'm going to call this keychain R1. Now, the key numbers must match. So I'm just simply going to say key 1, and then the key string, and remember the two key strings need to match. So I'm just going to say R1-string as my key string, right? So now I've defined the key. So if I say do show run keychain, or sorry, do show keychain, there's the keychain that we have right now. It's key 1. The accept and the send lifetime are both set to infinity right now. So we're going to leave it that way. But now what we want to do is we want to get back into the router EIGRP route EIGRP named configuration. Address family IPv4 unicast autonomous system 1. And so whereas with non-named mode, we would go to the physical interface, in EIGRP named mode, or 64-bit mode as you'll sometimes hear it referred to, we're going to go into the AF interface for the interface that we want to manipulate here with authentication. And remember, this is authentication, right? We're authenticating the source of the EIGRP packets. This is not encrypting all of the EIGRP information that's going between these two routers. So the first thing that we want to do after we get into interface AF interface serial 000 is we're going to call out our keychain. So we're going to say authentication keychain, and remember we called our keychain just R1. And let's see, does this tear down the adjacency with router 2 yet? And it doesn't, and we wouldn't expect it to. Again, remember in the discovery activity, I believe it was discovery activity 26, where we took a look at the control plane security with the routing protocols, and it's not until we say authentication mode in EIGRP and in OSPF, when we put in area 0 authentication, it would immediately start the countdown to extinction with the dead timer going from 40 seconds all the way to 0, and then we would see the adjacency sort of crash and burn and no longer be established. So now when I say authentication mode, we'll put a question mark in here. You see we have two choices. And really, if you're running 15.3 code or later, or I should say if you're running any code that supports HMAC-SHA, this really isn't a choice. You do not want to use MD5 because MD5 is considered substantially weaker than HMAC-SHA-256. And so we definitely want to stick with HMAC-SHA-256, and that's in fact what we're going to do here in this exercise. So I'm simply going to say HMAC-SHA-256, and now we need to put in a password. Now, it's important to note the password does not need to match the key string. Okay? So now between the two routers that I'm doing authentication, the key strings must match and the passwords must match, but on the same router. So here on router 1, and I'm going to pull this up in just a second, I'm just going to say password dash R1. That does not have to be the same. And you can see there our adjacency just went down, right? Because again, we've got authentication configured on one side of the equation, but not on the router 2 side of the equation. So again, if I were to say do show keychain, and then to turn around and say do show run section EIGRP, and hopefully, yep, okay, good. We got everything on the same page here. So what we're looking for, when I said do show keychain, right? So here's the keychain information. You can see that is the text of the key. That is the key string, R1 string. The name of the keychain is R1. When we come down to the AF interface, you can see that I call out the name of the keychain. However, in order to provide the SHA-256 hashed message authentication code password, the password does not match the key string, and they do not have to match. Okay? And in fact, they should not match, right? You don't want to provide predictable strings. Or, you know, in this case, the key string or the password. You don't want to make them predictable, so you should change them up a little bit. Now, when this goes to exchange with router 2, they do need to match. And the same thing here. When it goes to router 2, they need to match. We have to match them. And I'm not going to match them intentionally on the first try so that you can see that I'm not making that up. That in fact, these need to match between routers, but on the same router. Right? The key string is mutually exclusive from the authentication code SHA-256 password. Right? All right, so let's clear the screen here. So we're done on router 1. Let's save our config just to make sure. And if I come over here to router 2, if I were to say do show IP EIGRP neighbors now, you'll see that we only have a neighbor relationship with router 3. The relationship with router 2 has gone down. And let me see if, does the log even capture? No, we didn't get anything in the log. So here's what we're going to do now. We're going to do the same thing that we just did on router 1, except now we're going to do it on router 2. So I'm going to go ahead and say keychain, and we're going to call this R2, so that you can see that the keychain name is locally significant to this process. Now the key must match. So I'm going to keep, we'll say, and I think I use key 1. So we'll say key 1. Now the key string, remember on the other one I said R1, what did I call it? R1 string. Where was that at? Yeah, R1 string. So let's watch what happens here when I say R2 string. So we're going to use key string R2 string. Now we know that that doesn't match, but we need to prove that that is going to be enough to break the control plane, EIGRP control plane security here. All right, so there's our key string. So if I say do show keychain, sorry, keychain, not key string. So we've got our keychain, name is R2, locally significant. The key string for key 1 is R2 string. Now this is not locally significant, and we're going to see that that is in fact the case. Let's go ahead now and jump into the router EIGRP route, address family IPv4 unicast, autonomous system 1, AF interface serial 000, where again we're going to say authentication. Now, we've only got 2 choices here. We're going to use them both, but we need to make sure that we understand that as soon as we put the mode in, if there was an adjacency up on this interface, it would take it down if the other side is not doing authentication. So since we're already down, there's no harm in saying authentication mode. I'm going to say HMAC-SHA-256, and I apologize, put the password in here. So we left our password off. So now I'm going to use the correct password. So I believe we just use password-R1. So here I'll say password-R1. So we'll keep that the same. And then I say authentication what do we do? Authentication mode, authentication keychain. There we go. Authentication keychain. The name of my keychain is R2, and that's it. So let's come over here to router 1, and let's say debug EIGRP, and we want to debug EIGRP packets. And so let's see what we're getting here when we're receiving packets. And there we go, just as we would anticipate or expect. And let me say you all, so undebug all. So here's what we're looking at. When we take a look at this, you can see we've got an authentication mismatch. So we are ignoring packets from router 2 with an opcode of 5 because it's invalid authentication. So what do we know is wrong right now? Well, right now we know that the key string is what doesn't match. So let's resolve that. Let's conclusively show that if the key string were to match, show run keychain, or show keychain, sorry. So show keychain. So if the key string were to match, that the adjacency would come back up. So I'll exit from here. So keychain R2, we're going to go to key 1 and do show keychain. Let me make sure here that we've got, and you can see the keychain here was R2 string. So I'm simply going to say no key string R2 string, and then I'm going to say, and let's hope that I did not just wipe out, and I did. Just totally wiped it out. I should have just reissued the command, but that's okay. We'll get a little bonus action here. The bonus lab, so keychain R2, key 1, key string is R1 string. Now, we should, and there it is, perfect. The adjacency came up. So this conclusively shows that the key string has to match. So now what I'm going to do show run section EIGRP, is let's go back into the router EIGRP route process under address family IPv4 unicast autonomous system 1 under AF interface serial 000, and let's go ahead and say no authentication mode HMAC-SHA-256 password R1. We should see that the adjacency, and there you go, the adjacency just went down. And it goes down much quicker in EIGRP than it does in OSPF. In OSPF, we were kind of waiting around for between 30 and 40 seconds. Here, it's almost instantaneous. So then let's go ahead and say authentication mode HMAC-SHA-256, and let me put in an incorrect password. So I'm going to say password -R2. And let's see, does the adjacency come back up? It doesn't, and we're still debugging over here. So take a look at the debug that we're getting now. Now we're coming back and we're seeing that the debug, and actually let me kick that back off again. I think I stopped it. Yeah. So you can see we have an authentication failure. And there you go, authentication mismatch. Now, right, so now we get this authentication mismatch because again, we're using two different passwords on router 1 side and router 2 side. We don't have matching passwords for that HMAC-SHA-256 authentication hash. So it's going to cause this adjacency to stay down. So let's go ahead and resolve this and again conclusively show that both the key string and let me pull this back up. There we go. Let's say Control A. Both the key string and the authentication mode HMAC-SHA-256 command password, that those need to match between the routers. But again, on the router, they don't, on the same router, they don't have to match. And there you go. So we have, and I should say the key string name and the SHA-256 password do not have to be the same. Now, if you were looking at the lab, you'll notice that there is a mistake in the lab where they use, and where is it at here? I'm trying to remember where it's at. They actually use, and I believe it's on step 3, substep E, key string, or was it? Was there an error? I thought there was an error in here, but there may not be an error. I'm taking a look here at the steps to make sure. Key 1, key string secret 1, that's good. Key string secret 1, that's good. Key 1. And we've got secret 2, that looks good. All right, so everything actually looks good. So now what we're going to do, we've configured it on the AF interface serial 000. Let's go ahead and go into interface, AF interface serial 010, and we're going to do the same thing. We're going to say authentication keychain R2, and then we're going to say authentication mode, and this is going to be, again, HMAC-SHA, and whoops, and the password is going to be, and we'll use a different password here. So I'll say password R2 R3, and let's see if it'll take that. So it takes that as a password, and you can see we've just broken the adjacency because we've enabled authentication on one half of the equation. So let's now go ahead and jump on to router 3, and we're going to get router 3 set up as well. So I'm simply going to go into global config mode. We're going to say keychain, and I'll just call it R3 key 1, and the key string is going to be what were we using there? Can't remember what we were using. So I'm going to say key string R2, or actually let's just use R3 password. All right. So we've got our key string defined now. So now we're going to say router EIGRP route. We're going to go into address family IPv4 unicast AS1, then down to the AF interface serial 000. Do show IP interface brief. Let me make sure about that. Yep, serial 000. We're going to say authentication mode, HMAC-SHA-256, and let me go ahead and password R2, R3, and then authentication. We already did the mode, so now we need to pick off our keychain is R3. Now, is the adjacency going to come up? So the answer is no. So if I say do show keychain, you can see that we're using keychain 1. Or we're using keychain R3 as the name of the keychain with key 1, and the text is R3 password. However, over here, when I say do show keychain, you'll see that we're using keychain R2 with a different key string. So here's what I'm going to do. I'm just going to simply, we can actually create another keychain. So I'll say keychain, and we'll call this R2-1. We'll use key 1, and the key string, let me make sure we get this right, is going to be R3-password. And so on this interface, I'm going to go change the name of the key. So if I say do show run section EIGRP, you'll see that we were using R2, but we need to fix that. So let's go ahead and say router EIGRP route. Whoops. And then address family IPv4 unicast AS1 AF interface serial 010, and we're going to say authentication keychain is R2-1. So now we're referring to the correct keychain, and there you go, the adjacency is up. Now if I say do show run section EIGRP, you'll notice that I never removed the previous entry for the authentication keychain. You can only have reference on an interface to a single keychain. I cannot refer to multiple keychains under the interface. All right, and so this shows that we've got the HMAC-SHA-256, and if you're running EIGRP, this is exactly, if your code supports it, this is exactly how I would do the control plane authentication between the routers. All right, so now we're going to go to step 4. We're going to take a look at OSPF. However, I can't do it here because I don't have the code to support this activity. So you need to be at 15.4.1t. All right, so here we are. I'm in my INE control panel, and I'm basically just going to use the two routers here, router 7 and router 9, because if we take a look at the version, do show version include version, you can see that we're running 15.4.3s, right? And if I'm not mistaken, I believe that these are the the CSRs, the virtual routers, and we're running iOS XE software, right? So, but version 15.4.3, so we should be able to accomplish what we're looking to do. So here's what we're going to do. I'm just simply going to come in here and say router OSPF1, and we're going to put a network statement in, and I just use 10.10.79.0. So network 10.10.79.0, 0.0.0.255, and I'm just going to put this in area 0. Again, not so much a lab about having a whole bunch of stuff going. We're just going to show the keychain feature with OSPF between the two routers. So same thing here. If I were to say router OSPF1 and then throw a network statement in for 10.10.79.0, 0.0.0.255, area 0, we should see an adjacency form here between these two routers on the subinterface gig 1.79. And let's see what we've got here. So do show IP OSPF neighbors. All right, so there we go, and we're in the two-way state. Two-way druther, and let's make sure on router 7, if we were to say do show IP EIGRP, whoops, OSPF neighbor, sorry about that. We need to fix that real quick. OSPF, and I apologize for the tiny font. There you go. So we went from loading to full, so it finally kicked in there. So if I was to say do show IP OSPF neighbors, you can see that we have a full DR state with router 9. And so I'm on router 7 right now. All right, so now that we've got the adjacency up, that's really what we want, because now we're going to break it. So we're going to go ahead and we're going to secure the OSPF control plane by using keychains, right? And we're going to use that same HMAC-SHA-256. So the process is very much the same. I say keychain, we'll call this router 7 because that is locally significant. I'm going to say key 99. My key string is simply going to be, and we'll do the secret -1, right? Now, it's here where I'm actually going to say cryptographic algorithm. So this is where, and in fact, we're going to use SHA-512. So we're going to, again, we're going to make this as secure as absolutely possible. So HMAC-SHA-512, right? You got to love it. And you got to make sure that if we do 512 on this side, on router 7, we've got to do 512 on the other side. So now I've created the keychain and the cryptographic algorithm that we're using for the hash, which is HMAC-SHA-512. However, I still need to go under the interface. So let's go under interface gigabit Ethernet 1.79. And it's here where I'm going to say IP OSPF authentication, and this should look familiar, right? Whoops. This should look very familiar. And we're going to use a keychain and then the name of the keychain. Well, I called my keychain, excuse me, simply R7. So the difference, right, if we compare and contrast this with what we saw earlier with EIGRP, you can clearly see that we are not providing an additional password, that we simply provide the key string and that's it. With EIGRP, we had to give it a password as well under that AF interface mode. When we said authentication, we said authentication mode HMAC-SHA-256, we had to give it that extra password. With OSPF, we don't. So now, as soon as I say IP OSPF authentication, what should happen? Do show IP OSPF neighbor. We should be on the countdown to extinction, and you can see the timer should never go below 30 in a multi-access broadcast segment. And where are we at? We're at 15, right? So you can see as soon as I hit enter there, it's going to tear the adjacency down, because now in the header, in the OSPF packet header, in the authentication type and the authentication field, we have the hash in the authentication field, and the authentication type should be showing what? Well, we remember type 0 was null or no authentication. Type 1 was plain text authentication. Type 2 was what we referred to as MD5 authentication or hash authentication. So let's go back over to router 9 here. And we haven't done anything on router 9 yet, so let's go ahead and say debug IP OSPF adjacency, and let's see what the code is, or what it's returning with respect to the mismatched authentication type. And so as you can see, any kind of hashing authentication is going to be reported as type 2, and you can see that right here. Input packet specified type 2 authentication, and that is simply hash authentication. So in the previous video, where the only hashing algorithm that was available to us was MD5, we would say that that type 2 represented an MD5 hash. However, now with later releases of the code from 15.4.1 and on, that's no longer the case. You can't just simply say, oh yeah, that represents MD5 hashing, because it's not. So make sure you're aware of that, that you're still going to see type 2. However, now it is HMAC-SHA-256, right? All right, so we're back here on router 9. So let's go ahead and let's wrap this up by making router 9 match router 7 to bring our adjacency back. So we're going to go into global config, and we're going to say keychain, and I'm going to, we're going to call this keychain R9. We're going to do key 99, and the key string, which needs to match, and I'm going to have to go back. I apologize. Forget these things so quickly once they get configured. So here we're going to say do show keychain, and do show keychain, and key now was secret-1. All right, so we're going to go with secret-1 as the, sorry about that. We're going to go with secret-1, and we did use key 99. So let's jump back onto R9 here, get the telnet session open back up. So here we are. Whoops, sorry. So we're going to say key string is secret-1. Now, that's not going to fix things, right? Because we still have a mismatched authentication type. So I need to actually go into interface gigabit Ethernet 179. Whoops. 1.79. And we need to say, and this keeps beeping. I'm not sure why that's beeping. So we need to say, give me just 1 second here. I apologize. Hold on. I just lost my place. Or actually, what we forgot to do, let me get back into the keychain there. Keychain just dawned on me. I was looking at the keychain. So keychain, and we just called this, I believe, R9. We forgot to specify in key 99 the cryptographic algorithm type. And again, you can see we've got all kinds of choices here. We want to make sure that we are being as secure as possible. So HMAC-SHA-512. And now we need to go under the interface. So interface gigabit 1.79. And here is where we say IP OSPF authentication keychain, and then the name of my keychain, which is locally significant. And we'll see if it's locally significant or not. Does our adjacency with router 7 come up? And again, I apologize for the font size, very small, but I'm unable to make it any larger. I kind of messed around a little bit and was unable to get it to be any larger. So do show IP OSPF neighbors, and there we go. We're back to a full OSPF state with our neighbor. If I were to say do show run interface gig 1.79, there's the command for the keychain, IP OSPF authentication keychain R9. If I wanted to take a look at the keychain one last time, I would say do show keychain. And there it is. And so those are the final settings. And this is how you really lock down your adjacencies with authentication to ensure that not only are they next to impossible to reverse using that HMAC-SHA-256 hashing algorithm, but that they're going to remain secure And with the 512 bit key, you're going to be very, very protected. So we've got all of the adjacencies back. So this is actually the final Networking Academy lab that we're going to be working on for the semester. Again, this was lab 8.8-2, and we were looking at EIGRP and OSPF control plane security using keychains and HMAC-SHA-256 and 512 here with the OSPF hashing algorithms to control and to secure the control plane. All right, guys, thanks for watching. I will see you on Saturday. Enjoy the rest of your weekend. Or I'll see you on Monday night. Enjoy the rest of your weekend.